Okay, let's look at this cute face. Hello, Kapalapa. He's so cute. Where's the other ones? Oh, hi, Miko. How you doing? Come here. Okay, last one. Say hi. Okay, that's all. Here we go. And we're back to probability. What? We're so excited. Miko's excited. Okay, now we are doing some theoretical probability. Okay, because it's awesome. No, this is used to, instead of estimating based on data, this is, you're kind of, again, still guessing, still a guesstimate, but it is based on, like we said earlier, based on the number of favorable or possible outcomes, the number of favorable outcomes divided by the number of total possible outcomes. So we're going to use that formula to find the theoretical probability of rolling a number less than 5 on a die. Remember, these are very similar to questions you're going to see on your homework, so you might want to have Pearson pulled up while you're doing this. Okay, so finding the theoretical probability of rolling a number not less than 5. That's worded kind of strangely. So remember, we want the probability of, the number of favorable outcomes. So we're going to talk about what that means. And then we're going to divide by, the number of total possible outcomes. That one is usually, the denominator is usually the easier one to determine. How many possible outcomes are there? So when you roll a die, you're rolling to figure out what number 1 through 6 you're going to get, right? And so that means the probability of this event, so not less than 5, I'm just going to put E for event, has to be out of 6 possible outcomes, right? Because you could roll a 1, you could roll a 2, you could roll a 3, all the way up to 6. So then we want to figure out, well, how many are there in this favorable outcome? How many, when you roll the dice, is it possible to get not less than 5? Again, that's worded really strangely. Okay, but if you think about not less than 5 on a die, you have 1, 2, 3, 4, 5, and 6 are your only options. So out of those, you want to figure out the favorable ones are not less than 5. So 5 is not less than 5, and 6 is not less than 5. So that eliminates these two, those 4, 1, 2, 3, 4, because those are less than 5. So that's going to be 2 favorable outcomes out of 6, which is 1/3. Okay? Not hard, but you just got to make sure you're reading it carefully so you're not missing any of those terms. Okay? Speaking of not, the word not, that brings us to our next topic, definition, which is the complement of something. The complement of an event is basically the opposite of something. Okay? So for example, let's say that the event, in this case, is that you're a dog. Okay? If I were to survey a bunch of living creatures in my backyard, there are 5 of living creatures in my backyard. No, that's not accurate. Okay. Mammals. There we go. There are 5 mammals. If I were to survey all the mammals and determine what's the probability that they were a dog, it would be 3 out of 5, right? Okay. The complement of that is the event that you are not a dog. So it's not the event. So everything other than a dog would be that event. There's a certain way to notate that. So if I were to say the probability that you are a dog is represented by, let's say, capital D for dog. So I would write that as P parentheses D for dog. That's a D. Then the probability that you are not a dog is written like so. You write the event, so D, and then you put a little C that looks like an exponent. That stands for the complement, okay, of something. It is the event that something is not happening, right? So the probability that you have blue eyes. The complement of that is that you don't have blue eyes. The thing about complements is that when you add the complement with its event, it will always be 1 or 100%. So this is equivalent to 100%. Okay, so you're either going to be a dog or you're not a dog. You either have blue eyes or you don't have blue eyes. Okay, and when you combine those two options, if I were to add the number of mammals here that are dogs, 3, plus 2, that's going to equal the total sample space, which is 5. Okay, 3/5 plus 2/5 is equal to 5 out of 5, which is 1. Okay, sorry if I over-explain that, but I just want to make sure you understand what that means. It's really just, again, it's a lot of common sense here. Okay, so you really don't even need to write this problem down. This is very, very simple. Ready? An average of 80% of Miss Coffee students are completing their online assignments. By the way, that's accurate data. That's average. Some classes are doing better than others. Shout out to third period. You guys are winning. But if that's my average number of students completing online assignments, what is the probability that a student selected at random will not complete their assignments? So the probability that a student, will say S is the students completing their online assignments, then the probability of not completing their assignments is going to be 1 minus 0.8. So basically 100 minus 80, because the percentage was 80%. So 20.2, which is 20%. Okay, you see what I mean by common sense? Like if 80% of them are completing their online assignments, then that means 20% are not completing their assignments. Okay, that's all that complement means. So I don't want you to, don't overcomplicate complement. Okay, let's do another one about kind of sort of related to that. And this is just a good example in general that you will have something similar. This is similar to the spinner. Look at the spinner problems on your Pearson homework. Okay, a bag of 20 marbles contains 5 blue marbles, 8 red marbles, and 7 yellow marbles. What is the probability that you select a blue marble? Let's write it in blue. Why not? Okay, so that's pretty easy. You have a total of 20 marbles. If they didn't give you that information, you know how you would get that information? You would need to add 5 plus 8 plus 7, which gives you 20. Okay, just in case you were wondering. So what is the probability that you will select a blue marble? That's going to be 5. There's 5 favorable outcomes. And the total possible things you can select, there's 20 possible things you can choose from. Okay, so 5 out of 20. Simplify that down to 1/4, which you can also write as 0.25, which you can also write as 25%. All of those are correct. Make sure you read the question to know how to answer. Okay. Now, what is the probability that you select a marble that is not blue? Doesn't specify whether it's red or yellow, just that it can't be blue. So here's how I would write that. The probability of the not blue, so the little complement there. Okay, guys, there's a much easier way of doing this than counting. You can always count the number of red plus the number of yellows divided by 20. But using this complement, I know that this 5 is the number of blue marbles. So that means the number of non-blue marbles has to be the total number, which is 20, minus that number, which is 15. So sometimes subtracting is the faster way. In this case, maybe not, because you could simply add 8 plus 7. 8 plus 7 is also 15. So either way, that gives you the number of not blue out of 20. Okay? But I'm going to show you an even easier way of solving this problem. Instead of actually counting this number, what I could have done to get this is I could have said, well, if I know that 25% is blue, that means that 75% is not blue. Because when you add up the event and its complement, it has to equal 100%. So another easy way of doing that is basically, well, what is 1 minus 0.25 or 100 minus 25? That's 75. Okay? Either way, whatever method makes more sense to you. You could also write this as a fraction, 3 out of 4, right? Because when you compare those two, the complements of each other, the 1/4 and the 3/4, when you add them, they have to equal 1, which they do. Okay? How are we doing on time? Okay. We're probably going to do 3 videos, sorry. But we'll end this one with this last part here about a sample space. Just want to make sure you briefly know what that term means. A sample space is all the possible outcomes of an event. So let me just show you this example, and it'll make more sense. Write the sample space if 2 fair coins are tossed at one time. So if I toss 2 coins, assuming they're not weighted, that's what the 2 fair means, it's not weighted. If I toss 2 coins, my possible outcomes are going to be heads and heads, heads and tails, tails and heads, tails and tails. So we write that out, and we use these little fancy squiggly brackets when we're talking about sample space. I don't know why, but we do. And you actually just are going to write out, I'm going to use H for heads. So I could have 2 heads. Oh no. Okay, I'll plug you in soon. Or I could get a heads and a tails, right? Or I could get a tails and a heads, because the 2 coins are different from each other. So it's possible that I could get a tails and a head. I mean, they mean the same thing, but that could happen, right? Or I could get 2 tails. So that would be my sample space. Does that make sense? Okay, so from here you can always find the probability of something happening. So like, let me just do one quick example before I end this second video. If I wanted to find what's the probability that you will have at least 1 heads, so at least when you toss the coins, at least 1 heads, then you would count up how many favorable outcomes. So this has at least 1, at least 1, at least 1, and the total possible is 4. Or I could do what's the probability of exactly tossing 1 head. So that excludes the heads, the double one. And so that's only going to be 2 out of 4, which is 1/4. So you might have some examples there. Okay? All right, so we're done with this video was, I guess, theoretical probability and complements and sample space, mostly theoretical. And so we're going to do one last little, hopefully it'll be a pretty short video, this last one, on geometric probability. Okay? Last one. Hang in there, guys.